All right, let's dive into a real powerhouse of statistics, the t-test. Have you ever worked with just a small amount of data and found yourself wondering, hey, are these results for real or did I just get lucky? Well, if that sounds familiar, stick around, because this is the tool that gives you the answer. So let's set the stage with a super common problem. Imagine you've created what you think is a revolutionary new teaching method. You test it out on one classroom and wow, their scores improve. But here's the million-dollar question. Was it your brilliant method or did they just have a really good day? How can you be sure it wasn't just random luck? This is precisely where we need a specialized tool. The thing is, we can't always test our ideas on thousands and thousands of people. I mean, that's just not reality most of the time. More often, we're working with these small, focused studies. A single classroom, a small clinical trial, or a pilot program. And that right there is where the story of the t-test really begins. Now, when you have tons of data, we're talking hundreds or thousands of subjects, statisticians often use a tool called the z-test. But there's a big catch. The z-test requires you to know the standard deviation of the entire population, which is basically a fancy way of saying you need to know how spread out all the data is. The problem? We almost never have that information. That's why the t-test is kind of the hero of small studies. It's designed specifically for samples under 30, and crucially, it works even when we're in the dark about that bigger picture. Okay, so now we know when to use it. Let's get down to brass tacks. What does the t-test actually do? At its heart, the t-test is beautifully straightforward. It looks at the average, or the mean as it's called, of two groups, and it answers one simple question. Is the difference between them big enough to be meaningful? In other words, is it statistically significant, or could that difference have just happened by random chance? It all boils down to comparing two averages to see if there's a real story there. And this brings us to a really crucial point. Not all t-tests are created equal. The right one to use depends entirely on the kind of groups you're comparing. So let's break that down, shall we? First up, let's talk about the most common scenario comparing two groups that are completely separate from each other. Like comparing apples and oranges. This is where we need our first type of t-test. This is where we use something called the independent t-test. And the key word here is independent. The people in one group are totally separate from the people in the other. There's no overlap. Let's go back to our classroom example. Imagine you have two different classes, taught by two different teachers, using two different methods. The students in Class A are not in Class B. They are two independent groups. Simple as that. So, what you do is measure the average test score for Group A and then the average test score for Group B. Then you'd run an independent t-test to see if the difference in those average scores is big enough to say, yeah, one teaching method was probably better than the other. But what if your goal isn't to compare two different groups? What if you want to track the progress of the same group over time? Well, that calls for a completely different approach. For this, we have the paired t-test. Think of this as the before and after test. You're measuring the very same subjects twice to see if some kind of intervention actually had an effect. Let's think about it this way. You have one group of students. You want to see if a special month-long training program improves their test scores. The subjects are the same people, you're just measuring them at two different times. So you test them before the training, then they go through the whole program, and then you test those exact same students after it's done. The paired t-test then compares the before scores to the after scores to see if the training made a real significant difference. You see the contrast, right? It's all about one group measured twice. Okay, we've covered the two main types of t-tests. So let's pull this all together into a quick and easy cheat sheet to make sure it sticks. The whole idea really just boils down to this. If you have two separate, totally unrelated groups, like two different classes with different teachers, you use the independent t-test. But if you have one group that you measure twice, like those students before and after a training program, you use the paired t-test. It's really that simple. So the most crucial point, the main takeaway here is this. Before you even think about formulas or crunching numbers, just look at your data. Are your groups separate or are they paired? The answer to that one question tells you exactly which t-test you need to use. And that right there is the key insight. The next time you see a headline about some new study or a promising pilot program, you'll have this little mental toolkit to look just a little bit deeper. Before you even get to the results, just ask yourself that fundamental question. Are the groups they're comparing paired or are they independent? Now you know exactly what that means, and you're already one step closer to being a much more critical consumer of data.